All right, well, let's get started. Hi, everyone. My name is Chris Doran. I'm a technical sales specialist for ITM Instruments. Thank you for joining us for our webinar today, brought to you by ITM University. Today's topic is the NFPA-70B Safety and Compliance with Teledyne FLIR. We'll be covering a good amount of information over the next 40 to 45 minutes, and we'll have a time allotted at the end of the presentation for Q&A. We do encourage you to ask questions throughout the presentation. Use the question feature or the chat feature to submit any and all questions. As you see, as they come in, a certain slide triggers something for you. So please submit them as the presentation goes on, and we'll have time to answer them in the allotted Q&A period. ITM and Teledyne FLIR have been working closely together for many years. We pride ourselves on being a leading distributor of Teledyne FLIR in Canada. This is a result of our dedication to offering you our product expertise, service, and our competitive pricing. Getting started today, the webinar is presented by John Gould, Director of Global Business Development for Condition Monitoring for Teledyne FLIR. John, I will turn the presentation over to you.
Thanks very much, Chris. I know it's a mouthful, but appreciate that introduction. Thanks very much for having us today. Look forward to speaking on this topic. Just wanted to get into our agenda, what we're going to kind of cover. I wanted to combine a couple elements here, obviously 70B being the focal point, but bringing into the discussion some of the 70E elements and just aligning those towards that 70B standard, kind of understanding the differences too. They're not quite interchangeable. A little bit of an overview on thermography for those folks who don't quite have a full understanding of some of the capabilities on that side of condition monitoring. Get into those value and benefits of adoption. So, doing it because you have to, but doing it because there's some benefit to the organizations. Talk a little bit about how we can help you in that journey, as well as some question and answer opportunity for you to ask any questions about these, any things you want further insight on. We're also going to do a little bit of a fun quiz at the end, so kind of pay attention. It'll be quick and easy, but we'll get into that once we get towards the end of the presentation today, and look forward to seeing how engaged folks were, and if you have questions as we go through, we can certainly address those. Okay. All right, so what is 70E, NFPA-70E? It really focuses in on the electrical safety program itself. Its focus predominantly is on protecting people as it relates to engaging in environments that have electrical safety hazards. So really there are 5 key elements here that are the components of that electrical safety program. So you have qualifications, assessments, hazards, job planning, and then ultimately leading towards reliability efforts in the organization. So we're going to talk to each of those in a little more detail. So when we talk about qualifications, what do we mean? NFPA-70E states a qualified person should be trained and knowledgeable in the construction and operation of equipment, as well as being trained to identify and avoid electrical hazards. So these are important components that the folks who are working and operating on these pieces of equipment understand what their operations are, as well as trained to identify and avoid any of those electrical hazards. Real important differentiation here too, as well as task qualified. So a person can be considered qualified to perform certain tasks while still being considered unqualified with respect to other tasks. Why is that important? So understanding certain electrical staff may have the capabilities to perform certain types of inspections or certain types of activities, and really understanding the task qualification as pertains to job planning and understanding what type of staff you want to have engaged on those efforts. Additionally, it gets into the assessment side of things. So understanding the hazards of the equipment and performing those risk assessments on those hazards. So things like likelihood of occurrence, what is the likelihood of potential failure, as well as the severity of the event, both impact operations and people. You need to be able to perform those assessments and document them so they help build out those safety plans that you need to perform those activities. Additionally, it calls for power system studies. Many of you understand and know that we need to have arc flash studies to understand what is the safe operating distance relative to PPE with approaching hazards, short circuit studies, as well as coordination studies for all key elements within that power system study as it pertains to 70E. When we talk about hazards, really what we're talking about is a type of PPE, insulated tools, test equipment, any barriers that you need relative to operating on energized equipment. So understanding that approach you will, in the visual on the bottom. It's really about our flash protection, understanding what are the tools, equipment, and PPE that you need in place as you get closer to the zero distance that's operating within that enclosure or that space. We talked a little bit about, the hazard identification, but the job planning portion in terms of the activities you're going to execute against working on those equipment. So documenting those tasks, identifying those hazards associated in the task before any work begins. So many folks will work with what are called hot work permits or energized electrical work permits that clearly outline not only the tasks to be performed, who's going to perform them, any lockout, tagout requirements as related to those tasks, what type of PPE you should be wearing and using during those tasks, as well as closeout and documentation procedures. So those are all critical components as it pertains to understanding those requirements within 70E. And like I said, the reason why I wanted to kind of bring this up at the very beginning is just to talk to the focal points on the NFPA standards really are about safety. 70E's focus is on protecting people, as well as 70B being focused on protecting and performing the correct electrical maintenance procedures throughout your organization. So the two elements do come together. It's just a matter of understanding the differences to help you and your clients as they enter into this area. So now we're going to talk a little bit about infrared. So understanding kind of how infrared and thermal cameras work, a little bit of the science behind it, just to kind of give a high level overview for folks who may not be aware. And just wanted to head into that. So how they work. The photons impact and that heat deflector element. So those photons are attacking, if you will, and we're capturing that information. And we're using the Stefan Boltzmann law to perform those advanced calculations that ultimately lead us into the ability to associate specific pixel temperature measurements within the camera, right? So we're going to be able to get all those and capture those values and associate colors to those data points and ultimately be able to produce your thermal image. Nice little herd of deer there. So that's really the basic science behind it. So being able to detect those photons, perform the calculation to produce pixel values for temperatures, and then translate those temperature values into the visual. So heat gets sensed by the camera. It can be very precisely quantified, not only to allow you to model the thermal performance, but also identify and evaluate the relative severity of any heat-related problems that you may see. So what is it? We picture a tank here, but really it's the process of turning infrared radiation into that usable picture. Right? So as we go into and use those different infrared technologies to do identification of potential problems or issues that may have, the heat signatures or the temperature differences are really what we're looking at and trying to understand, both as it pertains to that piece of equipment we're looking at, but also in comparison to other similar components and being able to perform temperature calculations across. So there's really no good way to identify something just visually. We need that thermal image to be able to support that. But why do we want to see heat? Why do we want to see those things? It's really important to understand that. So this is a picture of a fuse clip with 3 different fuses. And we have on here obviously an identified deficiency with a bad connection on here, and ultimately these types of situations can lead into significant problems, right? This is a substation that's blown up, usually insulation issues from transformers, an oil leak, different gases within the transformer igniting. But really our focus here is about predictive, preventative. How do we prevent and predict these types of failures from happening, and using thermography as a means by which to do that. So really trying to get to the point where we're trying to prevent the consequence of that failure as much as possible. Yes, we're going to find those problems. We're going to increase safety, but the ultimate goal is really to prevent those situations before they become issues. And a lot of times when we're focusing in with the customers and talking about their different thermal needs, we're talking about what are the consequences of failure for that type of equipment. Would it mean that the power generation stops? Would it mean that the facility is shut down because it can't produce the appropriate temperature to operate? Could it mean that the manufacturing line goes down because the motor failed and the conveyance system is now no longer usable? So really, it's about that consequence of failure that we're talking about. So being able to see heat and be able to see the images within context of thermal images are important, but really want to get a little bit more too on the resolution side of things. So basic statement with this is more pixels in your image equates to higher density of measurement points. I just want to provide that kind of in a visual state. So you have a grid here kind of showing various pixels that could be in some of a lower resolution camera. And then as we move to a higher resolution camera, we're getting more pixels and more information that we can target that specific temperature on the image more effectively. And really what it comes down to is less pixels are typically going to result in a lower quality image, or an image that's not going to be quite as valuable if you're trying to do analysis or troubleshooting. Having a general idea where a problem is okay for certain use cases, but being able to identify more specifically within the image where an issue may be resulting is certainly the focus that we need to. So kind of looking at it a little more deeper. So here we're looking at a series of motor banks and splice wires. So, taking this image in a lower resolution format, we're getting the temperature data that's average from 1 pixel covering the target area. So right here we can see it's 79.14 degrees Fahrenheit, and that's in that target area of interest. But as we kind of add more more pixels to the screen, we're starting to see the temperatures change significantly, right? So 98.7, 0.8, I'm not quite sure why it's that many points, but we have that type of scenario where the accuracy of the temperature with the number of pixels on target is certainly producing a better image. If we go even deeper, we're starting to get even more accuracy. So more pixels means more detail and more accuracy on target. So we're starting to see really where that temperature is more accurately depicted for that particular connector in this particular case. So there's 9 boxes now that are on that target. They're averaging the temperature, and the temperature average is producing that result on our camera. So as you're kind of working and understanding the number of pixels and the resolutions on your camera, this is a really good way to explain, why more pixels, why more resolution is typically better, and it all ties back to what the use case is for the thermal use. So we're going to move right into kind of some of the other modes of working with thermography. So arc flash safety, as we kind of talked to with 70E, it's really important. And understanding where the application of IR windows certainly is something that is going to help provide those customers a better overall experience when it comes to their thermal inspections, and just really kind of dive into those details a little bit more here. So that's an explosion. We're going to get to that. So what's the cause of an arc flash? These are the different ways arc flashes can happen. So cover removals, overloading or overheating circuits, wiring in a non-workmanlike manner. You can read the rest, but there are a lot of different opportunities here for an arc flash to be introduced as a potential hazard. And typically in your hazard assessments, you're going to look at these various means by which arc flashes can happen and identify the ways to mitigate or remove those risks as it relates to arc flash safety, right? So arc flash isn't necessarily going to guide all regulations, and we're talking about some worst case scenarios. But within electrical maintenance, it's really important to keep these pieces of equipment in good working condition to prevent the failure, or introducing failures, and also good service conditions that they're operating in. And when adjustments do need to be made or things need to be changed out, doing so in a safe and effective manner. And we can kind of see from a visual perspective here. I'm not sure how well the video comes across, but this is an example of an arc flash as it pertains to just to kind of provide that visual. No one's standing in front of it, fortunately. So in terms of safety itself, looking at 70E and 70B, the guides and documents, these are where you're going to find your requirements around safe equipment, safe PPE and distances and safety plans and all things like that. Those are the areas that I want to make sure that folks have a full understanding of what's required. And then the safety and efficiency, when it comes to electrical safety and electrical inspections, those are the two main monitoring this equipment and you're performing these inspection activities, we obviously want to make sure that our staff that are performing these tasks are doing so in the safest possible way. So let's talk about safety and kind of come back to that. So with IR windows, you know, it's pretty clear. We can keep the doors closed. We can keep workers isolated from that switchgear itself. And then in the terminology within 70, reducing the risk in the hierarchy of controls. So let's reduce those things. We're going to make sure that folks can perform the inspection activities in the safest possible way and understand why it's really important. And really where it comes back to or ties together is probably a good use case or study that we did. We worked with a manufacturer on this just to kind of point it through. So we did a little bit of cost analysis. Everyone says, well, hey, listen, you know, it's a great idea to install IR windows, but, you know, there's a cost to do that. How is this going to help me be safer, and how is it going to save money for me, right? So a little bit of a cost analysis here. So working with the paper mill, they're performing these inspections of about 150 pieces of primary switchgear. They're doing them annually. It's a pretty intrusive inspection for switchgear, and really understanding, you know, we're using a combination of infrared and ultrasound. They're done in a completely energized environment. Need to be in compliance with 70 and 70B to make sure that we're doing this correctly. It's done by 2 plant electricians, one required for removing the panel, and then a contract reliability-centered maintenance engineer who's actually performing the inspections themselves. They take about 150 hours to perform, so this is kind of the baseline for what this organization was doing in their current work practices. And this is kind of the analysis side, right? So taking the operation from the suit up section, so getting in the appropriate PPE, both the engineers and the electricians. We have a factor 2 for 2 electricians here. It's about 21 days, so 2 suit ups per day. We're getting 63 hours of time getting prepared for performing these inspections. You could argue the finer points here, but ultimately, you know, they're putting the stuff on, they're taking the stuff off. It's non-productive time. It's not time dedicated to the inspection actually itself. And then you get into the details on the actual tasks at hand. So the actual removal of the covers, performing the inspection, putting the cover back on, the time that the RCM engineer is waiting for the covers to be taken off and put back on, the electrician's waiting while the RCM inspector is doing his job, and the total manpower for just a single site inspection was 495 hours. And these are quantifiable numbers that they calculated and working with us. And the total manpower for the inspection was 558 hours of total time. And if we look at this as 543 of those hours are dangerous or high risk or unproductive labor. So a combination of all of those things where they're not really putting time towards active inspection activities. Now, taking that analysis, once they performed the survey we performed the survey when they actually implemented the IR windows. Let's take a look at the table now and see kind of what happened. So the suit up factors are gone now because they're using IR windows. So the time returned and savings is already immediately there. Taking it further into the operation, we're no longer removing covers, right? The electricians no longer need to actually be there to do the inspections themselves. Some inspections may differ. There may be some repair, replace things that are happening throughout the inspection process, but in this particular case, for problem identification, we're strictly focused on the inspection activity itself. So it went from the 590 some odd hours down to 30 hours of time to perform these inspections. That's significant in the fact that of those hours, 100% of that is productive labor. So really when we get into those man-hour savings, we can understand. So it went from 558 using 3-man team down to 30-man hours using 1. We're saving over 97% of the man-hours needed to complete the task. And before they would go in, they would do the scans, they'd open the cover door, they'd go through, and then after, with the IR windows being installed, we're able to perform those much more quickly and easily. In FLIR, we have several different options around this. So understanding what's inside the cabinets, what needs to be monitored through an IR window. So the first set of windows we have are a series of circular styles. So from 2-inch to 4-inch IR windows, it really depends upon what your targets are and what you're actually looking at and examining. So understanding those things in a little more detail, placement on those things, understanding, how many windows would I need potentially for a particular cabinet to make sure I can see all the targets. And that's where our team can work with you to identify placement as well as the quantities you may need. And we see this being used in multiple applications as well, not just in high voltage switchgear. We see it in control panel cabinets, other motor control center type applications, as well as any areas where you're trying to avoid staff entering unsafe environment to work in. And additionally, we also offer what are called large format windows. So if you have larger areas that require inspections, where you need to have a bigger window installed to accommodate the cabinet or the space and really be able to understand where we can implement those in the appropriate places. So just pointing out, we have a couple different solutions there to address those arc flash safety concerns. And it's something working with our clients and you working with yours just to understand, IR windows is something that are very important. We're starting to see more manufacturers actually produce those cabinets with them already installed. And people are recognizing the ability to create a better, safer work environment and also improve the efficiency during the inspection process overall. Okay, and now we're going to kind of transition over to the main event here. So 70B. Really want to just point out the purpose of the standard, and this is pulled directly from their literature. It's for practical safeguarding persons, property, and processes from the risks associated with failure, breakdown, or malfunction, and a means to establish a condition of maintenance of electrical equipment and systems for safety and reliability. So anyone who's read through the inch-thick guidance certainly can understand. They're very explicit in a lot of their documentation. They provide a lot of great detail and insight on how to properly maintain electrical equipment, both from the tasks that should be performed as well as the frequencies that those tasks should happen. And really what we're wanting to highlight today are what are some of the things, what is new in the standard. So the standard was rewritten just last December for implementation in 2023. So it is now effectively a part of the standard. And we just want to kind of walk through and point out some of the key differences that are things that you can focus in with you and your customers as you work through these scenarios. So what is new? The key takeaway I want you to have from there is that this is a guidance providing, it affects both all process, procedures, as well as documentation requirements. And we're going to go into those very specifically. The biggest of which is thermography has now moved from a recommended activity to a required activity. So all the references to thermography within the NFPA-70B guidance focus in on that specific task, where it has become a requirement now of compliance with 70B. So when we talk about procedures, what has changed? Moving from recommend to required, the condition-based requirements around those things, detailed procedures by different asset classes, so the different type of electrical assets that you would be inspecting, providing those detailed procedures within the documentation. The people side, so understanding the role of the electrical maintenance program coordinator, as well as qualifications of both the testing personnel and the thermographer themselves. And lastly, documentation, so understanding delta T, so temperature differences, test records themselves, as well as calibration requirements that are all an important part of this standard. So moving right into the procedure side. So what I've done here is within those top line plain English explanations, I've provided the specific reference to the NFPA standards, so 7.4.1, 9.3.1, and 9.2.2. So when you feel like you have some free time and you want to pull up that guidebook, this is specifically within the documentation where we're talking about those things. So pointing out here that infrared thermography shall be used when required to verify temperature differences, and the two components there, similar components under similar loading, and then comparisons between electrical components and ambient air temperatures. Those are two acceptable means by which to perform the comparisons. A very important point of note here is that when we consider loading requirements, the NFPA guidance does suggest that those components need to at least be under The condition-based components of this. So understanding we have to be able to document the current equipment condition, and there's some very specific guidance on how to do that within the documentation. And that electrical maintenance program itself needs to document and codify what those things are, as well as track them over time. So this is not just a one-time activity. You need to be able to focus in and develop a good working list of what your current conditions are, because that does feed directly into the frequency of thermal inspections as well. And then those procedures themselves, most organizations will focus on manufacturer requirements, but the documentation does provide some very good insights into the very specific things that need to be done. As I said, if you don't have a program in place today for an electrical maintenance program, they do provide quite a bit of insight into the tasks that should be performed and the intervals at which they should be done. And then moving into the people side. So there's a role of electrical maintenance program coordinator. They need to be defined within your electrical maintenance plan. And this person's responsibility, among other things, is the evaluation of the equipment to determine scope and frequency of maintenance. So this person could be an electrical, could be a maintenance person, it could be your electrical supervisor, it could be a plant manager. It just needs to be defined, and they're ultimately responsible for the content of the electrical maintenance program itself, but having that role clearly defined in the new guidance as well. Personnel side, so understanding that they need to be qualified to perform the test procedures themselves. So this means any person who's responsible for conducting electrical maintenance is going to be trained in specific tasks, testing methods, test equipment, and PPE usage as applicable, and any of those hazards that are associated with the electrical equipment or system being serviced. So I think you're starting to see here where this is where the tie-in to NFPA-70E comes in with 70B. We're going to need to have all that information documented to be able to feed into and determine that our staff are properly trained to perform those activities. And I want to point out here as well, this is not just thermography, right? This is any test methods or testing equipment that's being used to perform any electrical activities or electrical testing that's done. It's not just thermography, just to be clear. And then the operation of the actual test equipment themselves, they should be qualified to operate the test equipment in those usage of tests to be performed. So understanding not just anyone can pick up a thermal camera, start walking around, snapping pictures. They need to be properly qualified and certified to perform that activity as they are doing so. And then shifting into the documentation side, the worst part of everything is documentation, right? So understanding a little more detail on the delta T requirements. So we talk about the two comparisons between the electrical components and ambient air temperatures. The loading piece is very important, as I mentioned before, but being able to document those things so that you as an organization can over time determine, based on similar load, are we having any changes in our temperatures, right? And there are NETA standards that get to specific actions and activities that should be taken, but really we need to make sure we're documenting these things in the most efficient way, and then maintain those records. Right, so there's a whole laundry list of different things that the test record should contain, but I really wanted to point out number 8 on that list is the indication of as found and as left test results where applicable. Where this pertains to thermography is if we identify a failure, we're identifying that as found, and then if any corrective action was performed, we need to also document that we made that repair and as left when we left that equipment at the completed state or completed repair. So being able to tie all those things together and understand that electrical maintenance program has specific requirements on documenting those things. I just wanted to call out very specifically this as found and as left. And then calibration, right? Test equipment calibration, it needs to be traceable by recognized national standards. And why is this important? You know, the cameras or any testing equipment, right? Whether you're using a temperature gun or you're using a multimeter or clamp meter, they need to be calibrated, and NIST is a standard example of such as the United States, but all of our camera solutions that we talk about when it comes to 70B do follow these NIST standards for calibration. And it's important that folks understand that they need to document those calibration certificates and any data around that. So kind of moving into kind of the overall value and benefits, right? Many organizations will perform these activities because they have to, but really what we're talking about is organizations that want to pursue this in the way beyond just checking a box or doing it because there's a requirement to do so. That's about that commitment to safety and a state of good repair. So being able to focus on safety is the core to your electrical programs, both for people and your equipment. And it really is going to provide a very pragmatic approach to maintaining your equipment with those standards. And they're very easily defined and applied. Just looking through the guidance and documentation, calling out the things that have changed, we're doing that for sure. But those standards have always been very much something that can be clear to the organization in terms of what they need to do, as well as applied in practice. Additionally, asset reliability improvements. Organizations that are being more proactive with their condition monitoring activities, they're going to see improvements in asset reliability. And really, that's the overall benefit of having a good electrical maintenance program, is to ensure that those assets are meeting their design intent, they're performing in a way that is achieving that organization's goals, whatever they may be. And then lastly, looking to maintain compliance with key regulatory agencies, as well as insurance policy requirements. We are starting to see on the insurance side of things that insurance organizations from a coverage perspective are starting to put language into their documentation about compliance with NFPA standards or industry standards. Sometimes they're being a little generic. I would check your policy or have your customers check their policies, because as they pertain to paying out claims, if there was an electrical system failure of some kind, they're going to want to see the documentation that you've been performing those thermal inspections as well as the maintenance activities as suggested by the standards and the guides that are in place. So how can we help, right? So understanding it's a combination of the right cameras, software, and training to ensure compliance with these requirements, right? We are absolutely the leader in thermal cameras. We want to make sure you're equipping your teams and your customers' teams with the right tools to perform those tasks. We also have the software to be able to maintain and keep proper documentation, to be able to do reporting, comparisons, things of that nature that are going to ensure you're compliant, but also provide good insights into your operational needs relative to those electrical inspections. And lastly, training, right? So understanding that your team is properly trained to meet those requirements from both electrical training as well as thermography itself. So being able to produce reports necessary for compliance with 70B, making sure your staff is properly trained. So these are things that we're really focused on here. Some of the other components that FLIR has really focused in on in the last few years here is, delta T calculations. So being able to perform temperature comparisons right in your camera, being able to add boxes and spots right on the camera as you're performing the inspections to quickly identify those delta T needs. As well as in our software, we've developed new tools around routing functionality. So with the electrical maintenance program, you're going to have a list of assets that you need to inspect. We have some routing capabilities in our software that can be loaded directly in the camera to ensure that you're going out and capturing all of your inspection data points, being more efficient, and then ensuring that proper documentation is in place. So these are things that we're focusing on and working with ITM over the years in terms of the different solutions that we offer, but really tying it all back to those 70B requirements and just making sure that folks are really in tune and understanding what those changes are and how they impact your customers and how they really need to be able to focus in on that proper documentation as these things move forward. So with that, I think we're kind of rounding things out here, but I do want to I guess we can open for questions now, or if you want to do the quiz first, Chris, you just let me know what works for you.
No, I think this is a great time to open it up for some Q&A. We have just over 20 minutes left until the bottom or top of the hour, and so there's plenty of time to get in any and all of your questions. So folks, again, we have a question and chat function within this webinar to submit all your questions in. Please, let's try and take advantage of having an expert like John with us today, so we can answer as many questions as possible. As a quick note, for any specific questions that we are talking about, a specific IR window for your application or a camera for your application, if you have those specific questions about pricing, availability, anything like that, I'll invite you to go to itm.com. You'll find our list of products, pricing, availability, data sheets, manuals, etc., as well as you'll find all the various ways that you can contact us and one of our experts within our team as well. That'd be via phone, live chat, or via email as well. We do have a slew of experts and both customer service and sales representatives within ITM who can help you and point you in the right direction and get you exactly what you need in terms of all the options that we talked about today. So again, please use the question and or chat feature to get in any and all of your questions. Let's see, we do have a few that came in. When talking about qualified personnel and the training along with it, I know ITC offers level 1, 2, and 3. Are there specific recommendations as to who should be doing the thermography, who should be doing reports, and or for maybe even a small business who is setting up a formal program, who should be writing that program?
Yeah, that's a great question, Chris. I mean, really where it comes to level 1 certification is typically going to be sufficient for an organization to have their staff complying with that need. When it comes to the reporting side of things, that's where your electrical maintenance program coordinator will ultimately be responsible. So in terms of NFPA compliance, that on the reporting side would be, just a matter of reviewing the documentation. There's no formal certified requirement for reporting other than you are reporting. And they, like I said, I only called out one point on that list as it pertains to the thermography side, but there are a series of about 12 specific requirements on documentation that are more in tune there. So we do find a lot of the reporting specifically on the thermography side are going to be those folks that are performing those level 1 thermography type folks.
Okay, perfect. So we talked about the frequency in which we do inspect. Do we, along with that, or kind of pairing together, do we have to increase, or is there a standard now that must be kept in terms of calibration of the camera itself, outside of following the NIST? But is there a certain frequency that customers should be using in terms of getting their cameras calibrated?
Yeah, so I think two questions. One, like frequency of inspection, was that the first part of your question, Chris? Yeah, so frequency inspection at a minimum is every 12 months for any condition 1 assets. And condition 1 assets are assets that are in good state of repair. They've been inspected with the annual frequency. There's been no change in operation or functions of the business. Category 2 and Category 3 fall into 2 separate categories relative to the status of the inspection frequency. So if you missed an inspection, now you're required to go every 6 months to perform the inspection until you are back to current. So basically 2 inspections need to be done, and then you can back to doing it annually. And then the last category would be things that are in not good condition or they failed inspection, then you continue to perform those inspections every 6 months. But at the minimum, all electrical components within your electrical maintenance program need to be inspected annually. As it pertains to your second question, you just repeat that for me one more time.
Basically bringing in now thermography within those inspections. Is there a certain frequency where in which a customer needs to calibrate their camera?
Sure. Yeah, so the guidance there is typically recommended based on manufacturer recommendation. So those fall into different categories based on the type of tool or you're using, but we do recommend that you perform that calibration based on whatever your camera recommendation is. So whether it's every 2 years, every 3 years, every year, it's going to vary based on, really comes down to the sensing technology itself and how frequently we need to have that reviewed.
Perfect. So again, just a quick reminder, if you have any questions, we have plenty of time left. Please use the question feature or the chat feature as well. We do have 2 questions that came in that are quite specific in terms of something that Bill and Francois, what I'll do is we'll address both of your questions directly offline so that we can kind of go a little bit deeper into your questions about calibration services as well as the training along with purchasing a new camera. I'll have either myself or one of our technical experts and sales representatives talk about and to address those specific questions. Another question that came in. So going back to the training, you know, we mentioned ITC and this, that, the other. Are there specific training options for just electrical thermography and or electrical inspection, or would it be recommended to have a general and or a broad thermography background?
So we do at ITC, we offer both. We offer a variety of different trainings, as you mentioned before, from level 1 to level 3. We also offer specific training around electrical inspections themselves. So it's not necessarily a 70B focus, but as a result of the electrical thermography training, all of the topics, skills, and knowledge that you would learn in that level 1 electrical training, you know, obviously with the thermography focus, would be directly applicable to this requirement in terms of certified staff. So we absolutely can accommodate, you know, those different types of classes. So the base thermography, as well as level 1 electrical, we have level 1 furnace inspections. We have, you know, UAV classes or UAS classes, ISO 184-360. So a lot of different types of classes. But for our recommendation with focus on NFPA-70B is that level 1 electrical certification that will align directly with those, the ability to perform those inspections in a correct and safe way.
Perfect. So another reminder, still have like, we'll say 10, 12 minutes left before we get to the bottom of the hour. So please use the question feature. We still have plenty left. Just quickly, if we don't have time to address your questions specifically, we do grab all the questions that we do get and we will handle them directly offline as well. So don't hesitate to put them in even as we're running out of time here. Still plenty of time left, that being said. John, I'm not sure if you'll be able to answer this, but do you know if the 70B is aligned with CSA Z462?
Yes, and Manny, are you on the call still?
Yes, I am.
And if you want to take that, as Manny is our resident Canadian FLIR representative here, he can speak to probably that a little more directly.
Yep. So just give me 1 second. There's something going on behind me. So yeah, actually, the CSA did. If you go to the CSA website, you will see that there's the 70B is a CSA 400. Let me just pull this up. Sorry about the noise behind me. So the CSA equivalent to 70B is the. Let me just pull this up. CSA's Z463 is the equivalent to the NFPA-70B. There is a little bit more focus on ultrasound in the Canadian version, but it is going to be revised soon in 2023 to be more in line with the NFPA version. NFPA-70E, if you go to CSA's website, is actually the Z462 colon the 21, and they actually say on the CSA website it's the identical one to NFPA-70E. So we have a feeling the 70B will also be implemented the same way for the Z463.
Yeah, a lot of these standards, you know, globally, internationally, NFPA tends to set the pace, if you will, for a lot of them, and then the local, more local or regionalized applications will start happening. We're starting to hear from OSHA right now in the States here, where OSHA is going to be adopting many of the changes as it pertains to performing their investigations around electrical safety issues. And if you're not in compliance with 70B, there will be, they're the, I would call the enforcement branch of electrical safety, but we all know that they do that. So yeah, so there is an applicable standard there, Chris. Thanks, Manny, for citing that more specifically.
Perfect, and that actually answered, well answered, the next question that we had in from Paul, where he did ask, is NFPA-70B applicable in Canada? I guess the best way would be yes, and it refers right back to the CSA Z463 that Manny referred to will be revised. Another question that we have is thermography recommended and or required in only older electrical panels, etc., or is it for all across the board?
It's a great question. We get that all the time, Chris. Absolutely required in all cases. So if you are a facility operator, if you're a manufacturer, utility organization, anyone who deals with the transfer of high voltage to medium or low voltage, so not residential, that's the only area that's really is not impacted, you are expected to comply with this standard. So if you have any sort of inbound service at a high voltage that's using transformers, switchgear to move power throughout your facility in any way, shape, or form, whether you have 10 assets or 10,000, the standards apply in all cases.
And if I may add as well, with the new functionality we have added to some of our cameras where you can do the reference image, it's actually a great idea. I already told a few customers to kind of, when you do first install of a new equipment, whatever they may be and all that, to do your first reference image to kind of create that baseline, and then you can always refer back to it when you do your next inspection. So it's a great way to kind of build that historical record, if you can. It's something we've added, a great feature we've added to our cameras recently. So.
Yeah, that might be a great topic for another training there, Chris. Our reference image functionality, being able to, as you're doing those inspections, pull up the previous one and bring over the camera settings as well as the status of that previous one. Certainly a real value out there for sure. I encourage any of the participants here to reach out to Chris to learn more about that, because we're getting a lot of folks asking the questions now. How do we got this major effort to comply with the standard, right? It's a big lift for a lot of organizations to move through. Our focus right now is really to prepare you, to educate you, and get you trained, but also to have the right tools to be effective in performing those tasks. So we certainly have those things in mind on our team here at Teledyne FLIR.
Perfect. And yes, I completely agree. Either myself or one of the participants, there is a survey at the end. So if that's a topic you want to handle, please enter that as your comments in the survey section once the webinar is completed. The next question we have from Koreo, I hope I'm pronouncing that correctly. In terms of the cameras being used in a residential electric space, John, I'm not sure if you want to touch on that, as you just previously mentioned. This doesn't really touch on anything residential. Maybe we can handle that directly. Again, as I mentioned earlier, any questions that we feel that should be handled directly offline and or that we're not able to get to within the allotted time that we have, either myself or one of our technical experts will contact you directly. I think that would be the best to handle directly. John, I wouldn't mind your opinion on that one as well.
I mean, there are different safety and inspection things you can perform in a home environment, but typically the standard doesn't apply there. There's certainly maintenance activities within 70B for panels themselves within more of a commercial or industrial space, and those should just be good general practices for organizations. But the last thing we need to do is have a homeowner start popping panels off or calling an electrician every time they need to do it. There's really no direct application on the residential side for this.
Perfect. Next question from Tim. Is it acceptable to hire a third-party company or inspection company to perform the thermal imaging at a manufacturing facility, or should it be taken care of in-house?
There's absolutely no restriction on that. You can absolutely use outside vendors or inspection teams. The only thing I would add is that most of those organizations are very familiar with this standard. Their businesses are growing as a result of it because they don't have in-house expertise to perform that. But what I've been doing and encouraging organizations is to look at the standard, and the fact that the frequency of inspections are kind of starting to make those third-party or vendor-led inspection activities become a little bit cost prohibitive. To be able to train your own staff to do those things, there is a cost savings there for sure, but there's nothing that prohibits an organization from leveraging an outside vendor. And I would say with the caveat that whatever reporting that they are producing back to you is to the standards for which you will be ultimately judged and graded on against. So your electrical maintenance program coordinator would be in close collaboration with that third party to be able to ensure the documentation is accurate and correct.
Perfect. Quick reminder, please use the question or the chat feature to get in your questions. Let's say we have about 4, maybe 5 minutes left to get to any and all. Again, if we don't have time to get to them, we will address you directly offline as well. For any questions related to, kind of segueing from the last question that we had in terms of in-house, or if you have questions about, pricing, cost, availability, the camera that you should be using for your specific application, go to itm.com, go to the contact us page. You'll find our phone number, email address, our live chat. Connect with one of us so that we can point you in the right direction. We can work with you hand in hand and directly to make sure that the best solution is provided to you. The next question we have is related to the software. Is Thermal Studio able to both be used for reporting as well as keep other testing data from PQAs or clamp meters or anything like that all along in one central space?
Yeah, it's a great question. So some of the functionality that we have within the camera provides the ability for an inspector to annotate or document additional factors. So one of the things we brought up with 70B was the load that the piece of equipment is under. So you may need to document the rated load for the piece of equipment, as well as what the 3 phases, each phase's load is under for that. So we have some ability to do what are called table annotations within the camera itself, where we can add any and all features and documentation needs you have around that inspection itself. So it's not separate from the radiometric image, but it does allow you to document all of those things. One thing too, Chris, I want to add is that we've created, and we're almost ready to release it, but an actual NFPA-70B inspection report that'll be a template for customers at Thermal Studio, no cost to you at all. We're going to provide that as a free offering that will allow you to properly document these 70B inspections. So it's something we're going to be coming out here, I want to say within a week or so. We're going to have it out for folks to use inside Thermal Studio Pro and be able to capture all those things and manage those reports successfully. So
that's fantastic. Okay, perfect. That's phenomenal. Okay, so we'll do one last question. It comes up relatively often. We talk about the importance of resolution when using and or selecting or buying a camera. Is there a requirement in terms of what palette should be used in terms of signifying a problem here or something to ignore, something that's not causing an issue here? I'll elaborate a little bit and should we always be using the iron palette?
Yeah, there's really no guidance specifically within the documentation, but that level 1 thermography class, we'll dive into, what is the right palette to use and in what situations. I think understanding, getting the appropriate component on target and consistently capturing it the same way, so that you can do more comparison over time, is probably the more important thing. Pallets, certainly, avoiding things like, hot or cold, pallets, iron, rainbow, those are all, sufficient to do that. You're going to get enough gradient and temperature difference. But what it boils down to is, the pixels tell the story. The picture provides an image, but the pixels tell the story. And you're going to find your max and your mins inside of your box measurements, be able to do things like, within Thermal Studio, we have a magic wand feature that allows you to click on a component and it will draw the polyline around the component, and you can move them around a little bit, but you'll be able to find those specific temperature points, as well as add your delta T's for similar components that are in that same field of view, or ambient air temperature as you're documenting it. So no real guidance from NFPA-70B on color palettes, but as I said, I think you're going to find application and uses based on the type of asset or equipment that you're inspecting that are going to be most relevant.
Fantastic, and that leads us right to the bottom of the hour, so we do want to be respectful of your time. So I will, John, thank you very much for the presentation. Thank you for sticking around and answering all the questions as well. Thank you to Manny as well for jumping in on that question regarding the CSA. So on behalf of ITM University, we want to thank everyone for attending the webinar today. We hope you found it informative and helpful. We are available, as I've said a few times already, to assist you in any way that we possibly can. Go to itm.com, find product lists, pricing, availability, technical sheets, manuals, our contact info to contact one of our experts directly, especially regarding everything and all the topics that we talked about today, all the solutions that we can bring to you that FLIR offers. Please contact us so we can help you and get you started there, or improve where you already started there. As mentioned earlier, at the end of this webinar, we do have a short surveys that we'd like you to complete. Your feedback will assist us in improving these webinars, as well as bring you topics that are of interest to you. We do have upcoming webinars over the next few weeks and months. Go to the training section of itm.com to find a list of all upcoming webinars, as well as a list of all previous ones as well, with links to the recordings, etc. And don't forget that as a thank you for attending the webinar today, your name will be entered in a draw to win $100 on your next online order. The winner will be announced on our social media channels, so be sure to check us out there. Once again, thank you very much to everyone for attending today. Thank you, John, for the presentation, and we'll wish you all a great rest of the day.
Thank you.
Thank you.